The purpose of this practice is to understand the performance of the Grinnell, Rockwell, and Vickers hardness test and to determine due to the penetration of metallic materials.
The material we used in this practice was 1045 and 1018 steel, a hardness Grinnell, a hardness Rockwell, and a hardness Vickers machine, and bakelite sample.
This is the Rockwell machine, and here is the weight lag that for this procedure we set 385 kilograms. We are going to start with the steel 1080. We set the sample, and this is the indicator, and we turn out the sample, and this is going to do 2 laps, just right here. Now we're going to push the lever, and the indicator is going to turn back until it stops. Now we're going to turn the light. And for this we're going to use the C numbers. These are used for hardness materials like the steel, and this one it's like 16.8 hardness or Rockwell. These are the marks that the machine does, and we're going to repeat the procedure one more time for the 1088 and 2 times for the steel 1045.
We're going to use this machine for the Grinnell test, and we are going to put our sample here. This is the elevator screw. Using the hand wheel, we are going to put this in the top. We're going to look at our pressure gauge. This has to be in 3,000 loading kilograms. We're going to pull the lever, and we're going to count 11 seconds. And we're going to push it again. After that, we are going to use our hand wheel. We can see the mark right here in our piece. This is the piece 1018. And after that, we're going to look at the diameter of our mark. Our diameter is 3.6. We can look at the Grinnell hardness numbers, and we can see that for our diameter, we can make the conversion to millimeters for load of kilograms. Our diameter was 3.6, so our load would be 285.
This is a Vickers hardness testing machine. The first step is set our sample over here, and we need to focus with the microscope the image. Once we have our image focused, we move the denture so the denture will penetrate our sample. We need to press this button, start, and as we see, the denture will penetrate the sample. We wait a few seconds, we let the denture works on the sample, and we do the same operation with the steel 1045 and steel 1018. Once it is done, we back to see in the microscope our sample, and we need to focus the figure that the denture has made in our sample. Once we have do it, we need to take the numbers, and in this case the red line indicates 25, and we need to do the sum with our black numbers. In this case it's approximately 3, so we need to sum 25 plus 3. So next step is to make the sum. The red line indicates 25, and we need to sum the black number. In this case is approximately 23. So the sum is 25 plus 23. We have 48, and we need to write the number over here. We do this twice, and once we have the result of our average, we need to find this number in this table, 80.6, and the result is 2235.
These are our obtained results from the Brunel hardness test, and well, we have the diameter, the average of the diameter that we measured from both of the samples, the practical and theoretical results, and the investigative results. To calculate the theoretical result, we use this formula. We have that F is the force applied in kilograms, D is the diameter of the indenture, and Di is the diameter impression in millimeters. For the Rockwell hardness test, we use the C subdivision numbers, which are used for the harder materials. We don't have a formula to calculate both of them, we just obtain them by the process. We have also our obtained results from the Vickers hardness tests, and well, we have the diagonal average, the practical and theoretical result, and the investigative results. To calculate the theoretical result, we use this formula. First of all, we have to make the conversion from microns to millimeters. And well, we have that HV is equals to 1.854 per node and over the diameter impression square.
What we could observe in this practice was, for any hardness test, it's important to consider that the surface of the specimen should be flat, clean, smooth, and perpendicular to the indenture, free of oxides, rust, and lubricants. The thickness of the specimen must be at least 8 times the depth of the impression. The procedure needs to be in room temperature. The main difference is that each hardness test measured materials of different fragility, HR for hardness materials, HB for medium hardness ones, and HV for fragile materials. The higher the number, the harder the material. The Brunel hardness we determine by forcing a hard steel of a spiceful diameter under a spiceful load into a surface of a material and measuring the diameter of the indentation left after the test. In Rockwell test, the indenture was set into a sample at prescribed meter load. A major load was then applied and held for 11 seconds. The force on the indenture was then decreased back to the minor load. The HR number was calculated from the dip into the indenture. Finally, in the Vickers hardness test, it was used a diamond indenture to make an indentation which was measured and covered to a hardness value. The specimen surface must permit a regular indentation shape, a good measurement. The diagonals of the indentations was measured using a microscope and the HV calculated with this.
The results obtained in the practice were very closer to the theoretical ones. This shows that the procedure was well done. After comparing the results, we proved that in every hardness test, the 1018 steel sample was weaker than the 1045. Here are limitations in the test. For example, in the Rockwell test, the minimum load is 147.1 newtons, and the maximum is 1,400 newtons. However, workshops or foundries often require test loads of smaller or bigger loads. There is no Rockwell scale for tests on cast iron and for steel sheets thinner than 0.15 millimeters. For Brunel and Vickers methods is the fact that the indentation is measured optically, which includes the danger for measuring errors. Also, in Brunel tests, on cylindrical surfaces are not possible. One interesting data in the hardness test is that the results are represented in HV, HFV, or HR in honor of his inventors. There is a relationship between the UTS and HV. 3 point UTS is equal to 500 HV. With this, it's possible to convert their units. The only way to know the HR is with the machine test, and there are subdivisions with letters for different types of materials. The last important thing to say is that the methodographic procedure favors treatment and subsequent examination in the beaker test for watching properly the microstructure of the sample in the optical microscope. Among the different measurements that can be in the laboratory, hardness testing is one of the most important in mechanical testing. From this practice, I learned important things. We can see what metal is stronger than another. How can we use them under different circumstances? I really enjoy this practice.
This practice was very interesting because I understand the importance of hardness tests in the industry. This process shows the resistance of the material's components to different applications. It allows us to give our final product a better quality.
I really enjoy this practice because it's awesome how with the hardness test it's possible to determine how material is harder and even if they look the same.